Hi learners, welcome to the course. Our today's topic is data warehousing implementation. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at IARE Hyderabad. Today I'll cover the topics are we're going to build a data warehouse. So what are the requirements and factors and functions we'll need? We'll discuss about that. The factors are business factors and other technological factors. In that, we will see what are the design consideration we need while we are going to design a data warehouse. What are the data contents are there? How many data distributions we need for that? And what are the metadata repositories there? Right? We will also check what is the performance consideration for to make a data warehouse. Let's start. Building a data warehouse. So there are two reasons why any of the organization that is considering the data warehouse, that is very critical. Why they cannot implement, why cannot they set up a data warehouse? So there are two factors for that. Like first factor is business factor, second factor is technological factor. So on the basis of these of the two factors, any of the organization, they can tell they cannot implement a data warehouse, or they are going to implement a data warehouse. So for that they need to collect the factors related to business, and they need to collect the technological factors related to their business, right? So first is business factor. So what is business factor actually? In that, business users, they want to make a decision quickly, right? So who will be the business users? They want the business at the top level, but for that they need some of the decision. They need to take some decision for that, right? So for that they need prediction. They need some of the like we can say facts, so that they have to be very quick, and rather than that they have to be very correct on their decision. So for that they need all of the available data that is available into the data warehouse, right? So that comes under the business factor. So they need these type of business factors. What about technological factor? In that, to address the incompatibility of operational data stores. What does it mean? It means the all of the operational data store that is storing, that will be incompatible. Rather than that, we have to run that, we have to implement that, right? So for that, the IT infrastructure and IT infrastructure will be needed. Okay, so for that, the IT infrastructure will be needed, and we know that that is changing very fastly, right? They're changing very rapidly. So their capacity is also increased on the terms of that, and also the cost will increase, right? So if the infrastructure is changing, the cost and capacity will increase, although the time will increase. So that we have to build the data warehouse. So in that terms, data warehouse implementation will be very easy, very smooth, right? So we only for that we need capacity and cost. So if we are having the capacity to implement a data warehouse, we are having the cost, we are having the finance for that, so we can implement a data warehouse. So that will based on basically transactional type of data, right? So for the business factors, we are having two types of approaches to build that, to consider that. First is top-down approach, and second is bottom-up approach, right? So what do we mean by top-down approach? Basically, this approach, it is collected for the enterprise data warehouse. It is collected for enterprise-wide businesses. So they are having some requirement, and they are going to decide, they are going to build a data warehouse for that. They are going to build the data warehouse for the enterprise data, right? Enterprise data. And what they're having with that, they can also use data marts. Data marts is nothing but that is also a part of subset of data warehouse that is having a business related data, right? So they will have the enterprise data and related data mart, right? So in the top-down approach, we need to consider these are the points. For the bottom approach, the data marts will be there, right? So data marts will be there. They will be integrated together. They can be more than 1, 2, 3. So they can be more of the data warehouse, data marts. They will be integrated, and we can say the combined together to form a data warehouse. So in this type of approach, we are going to use this type of approach widely, because this bottom-up approach help us incrementing building up the warehouse, so that we can develop and build the data marts when the requirement will be clear. So we are going to use the bottom-up approach. For that, we can help to increment the warehouse by developing and increasing the data marts. So the advantage of using the bottom-up approach is that they don't require any high initial cost. So initially, when we are going to use why we are going to implement the data warehouse, if we are going with the bottom-up approach, that cost will not be needed. Much of the cost will not be needed. In the lower cost, we can build the data warehouse, and also that will be the faster and faster implementation time. So that is very, very important, the cost and time. So here both of the things we are going to achieve. In the lower cost, we are going to achieve the higher implementation time, right? So the bottom-up approach, basically it is more and more realistic rather than top-down approach, but the complexity of the integration that can be vary. That can be sometimes serious, and that can be sometimes very, very low, right? So that only is the problem on that. Otherwise, that is best to use that bottom approach. We are going to use while we are going to implement the data warehouse. What are the different design considerations we will need while we are going to implement a data warehouse? So normally we can say a data warehouse data can be multiple heterogeneous sources, can have from the multiple heterogeneous sources. They are having operational data, they are having many other sources of data. So the data can be heterogeneous in nature. So that can also be into the query database, right? So that is also one of the reason why a data warehouse is difficult to build. So rather we have seen in earlier slide, so why the data warehouse is difficult to build. So that can be another factor, and so that if there are having the heterogeneous data in the query database, that can be a reason why the data warehouse will be costly and difficult to build. Data content is another factor. So the content and structure of the data warehouse are reflected in its data model. What does it mean? Means when we are going to see the content and structure of what is the structure of data, what is the basically content of the data into the data warehouse, that will be reflected by the data model that are having the different tiers, that is having the different levels. So in the different levels, we can check in the first tier only, we can check what are the content and what are the structure of data is there. Since the data model is the template, right? Data model is only a template that only describes the how the information will be organized within the integrated warehouse format framework, right? So the data model basically we have covered in earlier course, but rather it is describing how the information will be organized into the integrated frame house, right? Frame house of warehouse, data warehouse. And the basically data warehouse data must be in detailed data. That can be a detailed data. It can be formatted, it can be cleaned up, it can be transformated to fit into the data warehouse models, right? So that were the factors of the data contents in the data warehouse. So they are having these of the different functions. Metadata. Metadata basically it is defining the location and content of the data in the warehouse. Metadata is a searchable and by the users and to find the definitions of subject area. So basically in the earlier course we have covered the metadata definitions. The data definition, how we are going to write the query for that. So that is basically searchable by users. They can write the query for that. They can find the different definitions for that. So metadata is nothing but it is searchable by users. The collecting and maintaining and distributing the metadata is needed for the successful data warehousing, successful data warehouse implementation. Why? Because those of the tools that need to be carefully evaluated. So while we are going to implement a data warehouse, we will need the tools that is going to implement, that is going to distribute, that is going to maintain metadata, right? While it is going to be evaluated before any purchasing decision. So that is comes under the metadata repository. Data distribution. So that is also one of the factors while we are going to implement a data warehouse. So what does it mean? It is nothing but the data distribution, data warehouse distribution. In that, the data volumes will be there, right? So the data volume will be continue to grow because we are having that different type of operational data. We are having the historical data. We are also refreshing that data. So the data volume may be increased in number, right? So that is one feature of that, and therefore it became very, very important to know how the data should be divided across multiple servers. So the data obviously in the data model will be distributed, and that will be going to divided into the different servers. The data will be traveled for the OLAP servers and the other servers. So the dividation, that is very, very important. The data can be distributed based on the subject area, that can be based on the location, that can be based on the different times. So that can be on related to subject area, the domain knowledge, that can be on geographical region, and the data can be of any current month, year, right? Current time, current month, current year. So like that, the data distribution will be played into the data warehouse implementation. The other tools are there while we are going to implement a data warehouse. So a number of tools are there available that are specifically designed for the implementation of the data warehouse. So what are those tools does? That tool define a cleanup, that is defining cleaning of data, that is defining transformation of data, the movement of data for the end users. They are querying on that. We can report, we can do analysis. So these are the functions we are going to do while we are going to use the different tools. Performance considerations, right? So after we are going to gather the functions and different factors for the implementation of data warehouse, the performance is matters. The performance consideration matters. Actually, the performance level that are dependent, that are very very widely from the one environment to another, right? So that is widely that is widely spreaded into the one environment to the switching to the another environment. It is relatively difficult to predict about the data warehouse, how the data warehouse is going to perform for the specific data. So the following 9 type of steps we can take for that while we are going to design a data warehouse. So first method will be the choosing the subject matter, choosing the different domain knowledge, different area of matter. So that will be very very important while we are going to design a data warehouse. Second will be the we have to decide a fact table represent. So we have to decide what does the fact table means for that particular data warehouse. So we need to check the fact table, is it functional or not, what is going to do for the data warehouse, right? We need to identify the and confirm the dimensions of data. What are the different dimensions of data is there? Is it multidimensional? Is it 2D dimensional? What type of data is there in data warehouse? We need to identify and confirm that. Another is choosing a fact. Choosing the fact. So what are the different facts are there? What are the different data are there? Value are there? We need to check that. We need to store the calculations in the fact table. So what are the calculation will be there before we are going to design a data warehouse. So we need to calculate that before we are going to design a data warehouse. So that can be calculated by the fact table. So because of the fact table is there, we can have the different attributes, we can have different keys, so that we can have the idea, we can have the knowledge of value, facts. So we need to calculate that before we are going to design a data warehouse, right? We need to round out the dimension table. So what does this mean? We have covered the dimension table, right? So the dimension table having the different tables, that is fact table, dimension table, right? So the dimension table is nothing but the data about data, right? So we need to minimize the different dimension tables, right, in this phase. We need to choose a duration, particular time for the database. So in what time the data is going to save, what is the exact timing while we are going to design a data, how much time it will be there, what are the different time duration is there for the data warehousing. We also need to track slowly about the changing of the dimensions. So in the dimension table there will be changes obviously, so we need to track out that also in this phase. Next, we need to decide the query priority, which is the query written by the data warehouse manager, data warehouse architect, so that that can be in priority. We need to write the query in the priority, and for the different query models, right? So those were the different factors. So for the performance consideration, now we will take the technological factors for the performance consideration. So there are some of the factors are there, which is hardware platform. Hardware platform is an important consideration for that implementing a data warehouse when we are choosing a data warehouse server. So we need to check the capacity of the data server. For that we need to handle a high volume of data. So the hardware platform will be very very important while we are going to implement a data warehouse, because of we are having the high volume of data, we are having a large volume of data. We need to choose a right server and server capacity, right? because of it is having the large data and throughput. So we need to have the hardware dependency, right? Because of we are having the modern server that also supports us for the large volume storing and large number of flexible GUI. So GUI is nothing but the graphical user interface. So that is having the user friendly interface and flexible in nature for to fetch the different type of large databases. So the server, the modern server, that is also supporting for the for the different and easy nature of support to data warehouse, right? There will be the next factor, data warehouse and database management system specialization. So as the name suggests, that is the very large of databases will be there, and that they will be needed to process, right? So that will process the complex ad hoc query in a sort of time. So there will be the database management system and data warehouse specialization tools that will handle the different query in the minimum time. The most important requirement will be for that the data warehouse are performance and throughout and scalability. So for that, data warehouse management system will be the for that the performance will be the very important. Throughput will be very important. And scalability will be very important for that to consider the performance of the data warehouse. Different communication infrastructure, like the data warehouse users are there. What they require a relatively high bandwidth, large bandwidth to interact with the data warehouse, right? So, and they need to also retrieve, they need to also know about a significant amount of data while they are going to do the analysis of data on the for the data warehouse. So the different users, the end users, they need a large amount of data, large bandwidth of the data to interact with the data warehouse so that they can do the analysis part. This consideration having the that means the communication network is going to expand, and the new software and hardware will be added on that. So that can be if they will be purchased and added, so that will be the so the better communication will be occur. So this in this phase we need a good hardware, good software, and good communication structure, so that the data can be communicated very smoothly and frequently, and we can fetch the important data for their analysis. Different consideration for their implementation consideration. So what we will have while we are going to implement a data warehouse. So the first is very important, collect and analyze business requirement. So for the implementation consideration, we are having the different phases. So on the behalf of that, on the basis of that, we can judge how the data warehouse is going to implement. We can understand about the data and different phases we can follow, and we can achieve the our target to implement the data warehouse. The first is we need to collect and analyze different business requirement, right? Second is we need to create a data model. Third is we need to define a different data sources. What are the different data sources are there? What whether it is operational, whether it is historical. So we need to define the data sources in this phase. We need to choose a correct database technology, a right database technology. We need to choose the database access and reporting tools in this phase. We need to choose a database connectivity software. we need to choose a analysis and presentation software. So these are the different phases in the while we are going to implement a data warehouse in the while we are going to do the data modeling. So in the different three tiers, we are going to do analyze these of the seven different phases. We are going to achieve these in the data warehouse implementation. There will be access tools. So in the data warehouse implementation, that is only belief on selecting the suitable access tools. So we need to believe on the different tools who are going to access the data. So that will be very, very important. In that, we need to have a various type of data for that can be accessed by these data access tools. So first is simpler tabular from data. So what does it mean? In this type of data, we will have the simple data that is having the tabular tables in the formation. So data will be in tabular form. Ranking data. So there the ranking data can be there. In that, the multi-variable data will be there. Time series data can be there. Graphic and charging and pivoting data can be there. Right? The other function is data extraction, cleaning and transformation. And then we are going to migrate. So in that, the timeliness of data delivery to the warehouse will be very, very important. The tools must have the ability to identify the particular data, and then they can be read by the conversion tools. So we will have the conversion tools. So the ability to identify the particular data that will have by these of the different tools. The tool will support obviously the flat files, the index file, the other data sources, since the corporate data is still in this type of data delivery. So rather all the data will be there in the data warehouse. This tool must support these of the other type of data sources, that is having the flat files, indexed files, etc. The tool must have the capability to merge the data from the different data stores. So these of the tools will obviously going to help the implementation and merging of the data. So the ability will be there to merge the all type of data together in the one format. Data should have the specification interface to indicate the data that is going to be extracted. So the specific interface will be there by that will be suggested by tool, and that will be extracted. The data should have the ability to read the data. So that will be read data from the different data dictionaries. So the tool that is also having this type of ability. The code that will be generated by the tool, that should be completely maintainable. So that is the factor while we are going to implement the data warehouse. So the data we are going to generate, the code we are going to generate, that will be completely maintainable in nature. So the data warehouse, the database system must be able to perform the loading data directly from these of the tools. So in the loading phase, the data, all of the data is going to be uploaded into the data warehouse system. So the ability to perform the loading of the data, that will become from these of the tools. Data replication, that is another phase of the data implementation. So in that the data replication or data moving takes place. So to place the data to a particular work group in the from the localized database, that will be the data replication of the data. So for most of the company use the data replication server for that. So that type of server is going to copy they're going to copy their most needed data to a separate database. So for this type of data replicated data that is going to save store onto particular separate data warehouse, separate database. So there will be database replication servers for that. Metadata. For the implementation phase, the metadata will be very, very important. So it is nothing but it is specifically the roadmap to the information that is going to store into the data warehouse. It defines the all elements and their attributes. So next function is data placement strategy. So next consideration is data placement strategy. So as we know, a data warehouse that is grows together with the while the data is updating, while the data is going to grow. So in that terms there will be at least two options for the data placement, right? So the first, we can say, there will be the we need to put some of the data into the data warehouse, so into the another storage media. So first we can do the data warehouse data we can store into the different type of media storage, right? So the second option will be we need to distribute the data into the data warehouse across the multiple servers. So these are the two placement that can be occur while we are going to implement. The user at the user level, the users of data warehouse that is going to classify on the basis of their skill, right? So what are the skills they are having? On the basis of that, they will be accessed for the data from the data warehouse. So on the basis of their skills, they are going to be divide the different type of data into the while we are going to access the data. So the users they will be divided into the three of the classes. For that, the first class is casual users, second is power users, and third type of users are expert users, right? So the casual users, they are the casual users. They are most of the comfortable in the retrieving the data from the data warehouse. So they will have the predefined formats and they will run the pre-existing query and report, right? So the casual users, they are going to use the predefined format, the data which is kept predefinedly. They are going to use the pre-existing query and reports. Rather than that, the power users, they are having the predefined data, right, as well as user-defined query, right? So so that they can create a simple and ad hoc reports. So in this, that is the difference. They are going to make the report. These users can do the drill down operations, and they can have the access to see what are the different dimensions of data, what are the deep data is there, what is into the data deeply. So they will have they will perform the data drilling into the data warehouse on the multidimensional data. So these users may have experience of using reporting and query tools, right? So for that, they will use different type of reporting and query tools. Rather than that, the expert user, they are going to create their own complex query. They're going to write the different complex query, and that they will perform the standard analysis on that, so that the information they can retrieve. So these are the users, they are having the knowledge but about the use of query and report tools. So they will have knowledge, and they will write their own complex queries. Data warehouse implementation, in that we need efficient computations of data cubes. The data cube can be viewed as a lattice of qubits. So that was nothing but what was that? The data cube. So that can be called as a lattice of cubites. In that, the data, the bottommost qubit is the base qubit. So the base is called as a base qubit. The topmost qubit apex contains only one of the cell. So how many qubits will be into the multi-dimensional cube with the L levels, we need to find out. So for the efficient computation of data cubes, we need to know about the base qubit, we need to know about the cells, what are the how many qubits we are having for the multi-dimensional data. The materialization of data cube is important. So in that, the materialization for the every qubit, we can say full materialization, we can say none of the materialization, or some of the partial materialization will happen. So these are the three phases of materialization. In that, the full materialization will happen, no of the materialization, and partial materialization will happen. That selection of which of the qubits to be materialized, that we need to decide. So for under that, which of the qubit will be accessed first and that will be materialized, we need to identify that. So that can be based on the size, sharing, and access frequency. Different cube operation will also affect that, because the cube definition and computation in the DML query we will write on that. So here is the query to write for the sales dimension. So for that, we are having a different dimension tables: item, query, city, and year. So for that, we need to write a cube definition in the DMQL language. For that, after that, we need to transform that query into the SQL-like language. We need to transform that. We need to change that query into the specific SQL language. So in that, with a new operator Q that is introduced by the Gray et al. In 1996, that will be applied on that, and we will write the different query-like language for that. So for the in the earlier slide, the query we have written, so the query-like language for that will be, the syntax will be like that: select item, city, year, comma, sum of amount, right, from the sales queue by item, city, and year. So we need to transform that query into the SQL-like query. Again, we need to compute the following sum of the group by. So we need to combine that sum of the groups, and then we need to write the query for that. So what will be that? In that, for example, we are having the same example. For that, we need to write into the bracket date, product, customer, right? Again, we need to write a date, product. So that will be the group by different groups for to compute the different queries. In this phase of implementation, we need to write this group by syntax. For the cube computation, then in next phase, we can have the cube computation. For that, we need to apply the ROLAP based models and ROLAP based cubing algorithm. So for the ROLAP based methods, the efficient cube computation methods are there, which we can use. So those are ROLAP based cubing algorithm that is implemented by Agrawal et al. In 1996. Array based cubing algorithm is Zhou et al. In 1997. So also the bottom up computation method is implemented by Baer and Ramakrishnan in 1999. So that was different algorithm and methods named for the cube computation, while we are going to use the ROLAP based methods. In the ROLAP based cubing algorithm, there is sorting, hashing, and grouping operations are there that are going to be applied on the different dimension attributes of multidimensional data in order to reorder and in order to cluster the different tuples. So this type of algorithm will be applied for the sorting and grouping of the operations. The grouping is performed on some of the aggregates, like we can say partial grouping step. So that the sub aggregation that has the another name, that is partial grouping step. So the grouping will be performed in this space, in this phase of the cube computation. After that, the aggregate can be computed from the previously computed aggregate also, rather than from the base fact table. So that is also can be happen. The aggregate will be performed by the another previously computed aggregate, rather than we are having the fact table for that dimension. The multi-way array aggregation for the cube, in that we will follow the computation, we will follow the partition array into chunks, that is a small subcube which fits into the memory. So the partition array into chunks is nothing, that is a small subtype of cube that is stored into the memory. Next, compressed sparse array will be addressing will be there, that is in the we can say the these are offsets, these are chunk IDs. The compute aggregates in the multi-way, that will be followed by visiting cube cells into order of the that is going to be minimize the number of times that is going to visit for the each of the cells. Why? Because they can reduce the memory access, and they can reduce the storage cost. So in order to that computation aggregation, we can say that is having the multi-way property, in that we are going to visit the different cube cells. For that, we can minimize the number of times we are visiting the each of the cells. So we have to visit onto the cube cells so that we can reduce the memory and storage for that. We can also reduce the cost and time for that. So that was all about the implementation phase of the data warehouse. So what are the functions are there? What are the other factors are there? They are going to affect. We have covered that. What are the different phases will be? They can be occur. What are the different methods we can implement on that? We can apply on that. So we have discussed for the implementation of data warehouse. So this was all about the today's lecture. We'll meet in the next lecture. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.